All right, so let's continue the discussion. From the previous 2 weeks, we talked about some structure, right? That handle the main memory, but we haven't really talked about this unit, right? That's called the main memory yet. In particular, we haven't really talked about the properties of the memory or DRAM. So today, let's learn how DRAM actually works, and I guess why the reason why they are important for modern day workloads and why they are important for the performance, right? So let me first begin by talking about DRAM DIMM. Anyone heard about this word before? DIMM. Anyone? So let me rephrase the question, right? And I'll ask this, and you can answer in Thai, right? So let's say you want to go buy DRAM, right? Let's say you're upgrading your computer. It can be a desktop, right? You go to a computer store and you buy DRAM. How do you call a unit of DRAM? ขอคำถามภาษาไทยนะครับเวลาน้องไปซื้อแรมอะแล้วไปบอกคนขายผมจะเอาแรมเนี่ยจะเรียกมันว่าอะไรคือยูนิตหน่วยของมันคืออะไร so what's the unit of DRAM so what do you tell the store owner do you know the name of the unit not in Thai I mean I don't care about the Thai name because I don't think they exist but that thing has a name to people typing rigorously there's only one now so the name of that, but basically the name of this item, right, is called DIMM. It's memory module. The MM stand for memory module, right? Memory modules. หน่วยความจำครับ so DIMM stand for dual inline memory module, right? But if you go to the computer store and say, hey, can I get one DRAM DIMM? They'll be confused because no one uses it. Even in the States or everywhere, no one uses it. But just say, hey, I want one unit of DRAM, right? So if in Thai, like ขอ DRAM อันครับหรือแท่งหนึ่งอะไรอย่างงี้ก็ได้เหมือนกัน so that's actually the actual name of the thing. It's called memory module, right? And the way it works is you connect DRAM to what? So let's say you buy DRAM, where do you plug it in? Anyone built your own desktop before? So let me ask you, where do you plug in? Where do you plug in the DRAM? What component is used for that? The main board, right? Or the motherboard. And we connect it to interact with the CPU because at the end of the day, right? At the end of the day, the CPU is where computation is happening. And memory is where the data is being stored, including the program, right? The program and the data both being stored in the memory. So there has to be some way to transfer the programs and the data to the CPU so the CPU can run, right? This unit or memory modules is also connected to the processor side through this chip. It's another subunit to control the memory. We call this memory controller, right? We call this the memory controller. And if you have the ability to zoom into the DRAM, somehow you have this like electron microscope and like the ability to understand the circuitry level, the wiring of it, you'll see that it's broken down into smaller units. First, is the DRAM channel. Is the DRAM channel. Then it's the DRAM rank, bank, row, and the DRAM cell. The DRAM cell is where you actually store the charge. That's where 1 and 0 get stored. It's in the DRAM cell. And again, the DIMM stand for dual inline memory module. And during each time interval, right? During each time interval, the DRAM can only transfer a limited amount of data because you have limited bandwidth. Because when you want to transfer the data over, you transfer that in the unit of some bytes, right, through the wiring. And the wiring, because they're physical stuff, there's a limit. There's a size limit for that, right? And that dictates how much in the unit of time, in say 1 cycle or 2 cycles or 1 second, 2 seconds, how much data you can send over. I'm sorry, oh my God, she wants to play with the pen. Yep, now I lose my pen. And there's also the concept of memory level parallelism that we gain from how we structure the DRAM, right? So the way we structure the DRAM allow you to transfer a bunch of data to your CPU at the same time. Now my second cat is here, yay! And because the memory takes quite a while to access, right? So it's a better idea now that we have the load store unit in the CPU side that handle a bunch of loads, right? It would be a good idea that we can transfer, say, 8 loads at the same time. So instead of sending 1 piece of data, DRAM is capable of sending so many pieces of data in parallel. In the typical DRAM that you can buy for your CPU, this can be 8 or 16 or more. In the GPU, there's even more through the high bandwidth memory that the GPU uses, right? So this is basically the answer to this is yes, you can transfer more than 1 request at the same time, right? And the DRAM structure is designed to provide this. So we'll go into this detail on how can we build DRAM, right? The modern day DRAM, I'm not talking about the one that you might be able to buy in the future. Let's talk about what you can get right now, right? So here's a high-level overview of DRAM. We have 2 DIMMs. Basically, let's say you buy 2 DRAM DIMMs. You have 2 pieces of DRAM, right? The way you connect it to the motherboard is you plug them into the motherboard, right? So does anyone own the motherboard that has 4 slots where there's 2 color in them? To be more specific in Thai, let me answer this question in Thai as well. เวลาน้องซื้อเมนบอร์ดนะครับบางทีเราจะเห็นว่าถ้ามันมี4สล็อตให้ใส่แรมบางทีมันจะมีช่องให้เห็นเลยว่ามันมี2สีมีใครเคยสังเกตไหมครับว่ามีช่องเสียบ2สีมีอาจจะบางยี่ห้ออาจจะสีเหลืองสีน้ำเงินผมก็เคยเห็นบางยี่ห้อเป็นสีดำสีแดงก็คือแล้วแต่ยี่ห้อเลยแต่มันมี2สีเห็นชัดๆมีใครเคยอ่านคู่มือไหมของเมนบอร์ดว่าไอ้แต่ละสีคืออะไรเดี๋ยวขอยกมือกันก็ได้มีใครเคยเห็นไหมครับว่าเมนบอร์ดเรามีหลายสีเวลาเราไอช่องที่เสียบดีแรมบางทีมันจะมีแบบหลายๆสีเดี๋ยวเอารูปให้ดูดีกว่า so let me show a picture I guess of this motherboard right so here's just a sample image you can see right from my screen that over here the motherboard has this is where you install the CPU right and this is basically this rail with the color black and blue this is where you install DRAM where you put in the the memory stick that you buy like I guess the memory DIMM basically you plug this into this black and blue thing. The reason why there are 2 different colors is many modern mainboard comes with multiple DRAM channel. It comes with multiple DRAM channel. So let me go back to my slide so that I can go through them, right? So let's say you buy 2 DIMM. Recall from the image I showed earlier, there's a black and blue color, right? Let's say the black color is channel 0, the blue color is channel 1. So you plug them into the black and blue color. It means that the processor can access the data, right? In the channel 0, oops, sorry. they can access the data from channel 0 and channel 1 in parallel at the same time because they are two different physical channels that are both capable of sending out data, right? That are both capable of sending out data to the CPU. All right. So I just gave you an example in the case where I have two DRAM plugging into two different color on two different channel, right? On two different channel. Channel 0 will have one DRAM. Channel 1 will have one DRAM. What if by accident I have 4 slots, I plug my DRAM in the same channel? Now I have two DRAM, I plug it, both of them got plugged into channel 0. What happened? มีใครทราบไหมครับว่าถ้าสมมติผมมีเมนบอร์ดที่มี4ช่องผมซื้อแรมมา2แท่งอะแล้วผมปักลงไปในช anel เดียวกันอะสมมติมี channel 0กับ channel 1 2สีอย่างเงี้ยแล้วผมปักลงไปใน channel เดียวกันไปที่ channel 0ทั้งคู่จะเกิดอะไรขึ้นฮะตอบได้บ้างมีใครสงสัยไหมก็ถ้าผมบอกว่า channel 0มันเป็น physical channel อันหนึ่ง channel 1เป็น physical channel อันหนึ่งมัน operate พร้อมกันได้เลยคู่กันเพราะว่ามันมี controller ของมันเองมันมี bus ของมันเองทุกอย่างมีของมันเองหมดแล้วผมก็ปักลงไปใน2 channel ผมก็สามารถเข้าถึง data 2 อันนี้พร้อมๆกันได้ถ้าผมแบบ by accident คือผมไม่รู้สมมุติผมตีต่างผมจะประกอบคอมแต่ผมไม่แน่ใจว่าไอ้แต่ละ2สีนี่มันคืออะไรผมปักลงไปในช่องที่มันเป็น channel เดียวกันแทนที่จะเป็น channel 0 อัน channel 1 อันไปเป็นแบบทั้ง2 อันลงไปที่ channel 0ผมเสียอะไรครับถามนิดนึงผมจะเสียอะไรข้อเสียของมันคืออะไรครับ ข้อเสียของมันก็คือเราจะได้แบนด์วิดต์ครึ่งเดียว อีกครึ่งหนึ่งผมไม่สามารถ operate channel 1ได้ เพราะมันไม่มีหน่วยความจำอะไรปักอยู่ใน channel 1 channel 1ก็แบบโอเคเปิดเครื่องเสร็จ channel 1ก็ไม่ต้องทำงานอะไร controller ที่ channel 0ก็ต้องแบบ coordinate data ทั้งหมด แล้วมันก็แชร์ทุกอย่างเหมือนกัน Right. So basically, if you plug the DRAM both into the same channel, you lose half of the potential bandwidth that the motherboard can give you, right? Because you don't use channel 1 at all, right? By accident, because you are not aware of what they are. So that's the first thing that I want you to be aware. So that's a high level overview. What are the channels? The channel, again, is just a physical interface where you can send the address to DRAM. DRAM will give the data back to you given the address, right? So let's zoom in a little bit, right? When you buy DRAM, there's two sides of them. There's like a green board, right? And then there's a bunch of chips on it. There's a front side and there's a back side to that. Both of them are from different rank. The front side is rank 0. The back side is rank 1. There are two different chips on the front and on the back. Then they operate in tandem to make sure the data gets sent to you. So you can access the data from the front side and the back side, right? Through the way the controller handle the signal sending to these chips in DRAM. And then the black thing that you saw is actual chip, right? And most of the time, if you buy a normal DRAM, is the one not designed for server or anything, you will see that usually there are 8 chips in them. There'll be 8 chips in them. These are actual DRAM chip. And if you actually zoom in, so let's zoom into this DRAM chip, right? So let's zoom this into this box, right? And if you have the ability to see the circuitry, you notice that they are actually separated again into multiple banks. All of these banks share, if they share the same command bus that takes the command from the controller, say, hey, go get the data for this address for me. So it shares the command bus. And then, as I showed earlier, right, they will work in a way that whenever I have the data, I will send the data back to this share data bus. So they share all the bus, share all the wiring. But the time it takes to actually go and look for your data in each bank, it takes some time. So whenever I have the data ready, I'll send out the data. And because there are 8 chips on your DRAM, 8 of them would work in tandem to give you one cache block. So the two processors here, right? This whole thing is one cache block, right? Which means that if I have 8 chips working together to send one cache block worth of data, so let's say that's 64 bytes, each of this chip would send in 8-byte information, right? So of this is an 8-byte information. So that when they combine together, you got 64 byte. That's why we call this unit a rank, because if you think about it, right? Think about a rank in let's say military, right? When you have a military rank, it means that a soldier would march together. They would work together so that they make progress, right? And move forward. The way these chips works are in the same way. Each of these chips would work together just to get the same address that the controller sends. Say, hey, I want this address 100. All the 8 chips would give you each 8 bytes worth of data for that address 100 for the cache block. And they will send in total the 64 bytes data back to the processor, right? So again, to recap, the DRAM channel is physically connected to the processor and has their own data bus, command bus, and address bus. This channel is physically independent from other channels. And each channel has its own memory controller that sends a series of DRAM commands to read and write the data from the DRAM cell. Again, the DRAM cell is where you store the electrons, where you store the ones and zero information. And this allows you to actually give memory level parallelism, because I can ask for the data from channel 0. And while I'm trying to get the data from channel 0, the CPU can then ask for another piece of data in channel 1 at the same time. So both channels would work together, right, to send 2 pieces of data back to your processor. The DRAM rank would contain multiple DRAM chips, and they work together as a rank to send and retrieve the data from the chip, right? And because DRAM has its own clock as well, DRAM has its own clock. They're actually much slower than the CPU clock. Multiple DRAM rank can utilize the bus while the other rank is busy. So let's say rank 0 is busy to get the data. Basically, it's waiting for the data. Rank 1 would come in and use the bus, so that you take advantage of this dual inline memory model. You can have rank 1 and rank 0 work in tandem, work together in duality to get your data at the same time, using a shorter amount of time, basically. And the DRAM bank are inside the chip. The data are distributed across DRAM banks. Each bank can transfer data in parallel. This gives you memory level parallelism. They share a common command bus. So when I want, say, address 1, followed by address 2, followed by address 3, it would send each of these addresses, right, through the command bus in series. You cannot send those in parallel. So the first cycle has to be the first address. The second cycle is for the second address. The third cycle is for the third address. But let's say they all go to different banks. Let's say they all go to different bank. It does address, the first address, the second address, the third address all go to different banks. In that case, each bank would fetch the data in parallel. And then the controller is responsible for sending the command to the command bus so that the bank can get your data back to the CPU core in parallel, right? So that's it about the organization of DRAM, at least the high-level organization of DRAM, before we dive deeper into the operation of DRAM and talks about the memory controller. Any questions? มีคำถามไหมครับ อันนี้คือเป็นแบบ structure ของ DRAM ที่เราซื้อแล้วใช้ในเครื่อง มีคำถามอะไรไหมครับ ก่อนที่เราจะไปคุยเรื่อง memory controller ที่หลักๆนะครับก็คือยูนิตที่ใหญ่ที่สุดจะเป็น channel เนี่ยก็คือเอา DRAM แต่ละแท่งที่เราซื้อมาปักเข้าไปถ้าเราปักเข้าไปที่แต่ละ channel ปั๊บเนี่ยก็แปลว่ามันจะ operate พร้อมๆกันได้ เพราะเราจะมี1 controller ต่อ1 channel เพราะสมมติถ้ามันมี channel 0 กับ channel 1ไอ้ memory controller เนี่ยมันก็จะมี controller ที่ channel 0 ก็จะ control เพื่อส่ง data ของมันแล้วก็จะมี controller อีกตัวหนึ่งที่ channel 1 ก็ส่ง data ของมันแล้วไอ้สายไฟที่ต่อจาก controller อะไปที่ CPU มันก็จะมีของมันเองเหมือนกันก็คืออันนี้เป็นยูนิตที่ใหญ่ที่สุดแล้วถ้าซูมเข้าไปอีกเนี่ยก็จะเป็น DRAM rank กับ bank rank เนี่ยมันก็คือเป็นชิป8 ตัวทำงานพร้อมๆกันเพราะว่าแต่ละตัวมันจะส่งสมมติผมต้องการค่าขนาด64 ไบต์คือแทนที่ผมจะให้ชิปตัวเดียวมันส่ง64 ไบต์อ่ะมันจะทำ8 ตัวพร้อมกันแล้วแต่ละตัวมันจะส่งแค่8 ไบต์8 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 ไบต์แล้วตอนมาเอาส่งค่าจริงๆกลับไปที่ CPU อ่ะมันจะเอาแต่ละ8 ไบต์เล็กๆเนี่ยมารวมกันให้เป็น64ก่อนแล้วค่อยส่งกลับอันนี้คือ rank นะครับส่วนแบงค์เนี่ยมันมี command bus เดียวกับอันเดียวมี data bus อันเดียวแต่ว่าที่สำคัญก็คือว่าเวลาเราจะเข้าไปเอา data ใน RAM อ่ะไอเวลาที่ใช้เข้าไปที่ DRAM cell เนี่ยมันใช้เวลานานคือมันก็จะใช้เวลาอยู่ในแบงค์เนี่ยอย่างนานเลยจริงๆใช้เวลาส่วนนั้นอย่างนานตอนที่เราจะส่ง data กลับมันแป๊บเดียวเพราะฉะนั้นเราก็จะสามารถมี organization ในแต่ละชิปแต่ละตัวได้ว่าเฮ้ยเราจะมีหลายๆแบงค์แต่ละแบงค์เนี่ยมันทำงานพร้อมๆกันได้คือมันจะวิ่งไปที่ DRAM cell ไอตัว capacitor เนี่ยได้พร้อมๆกันแล้วถ้าผมได้ค่าที่ต้องการมาแล้วพร้อมแล้วเนี่ยมันก็จะส่งค่าผลลัพธ์กลับมาเลยบน Data Bus เพราะฉะนั้นเราก็ได้ Memory Level Parallelism อีกในแบงค์สมมุติผมมี8 แบงค์ก็แปลว่าผมจะสามารถ on average ถ้าผมเขียนโปรแกรมดีพอผมจะสามารถส่งข้อมูล8 ตัวพร้อมๆกันได้อ่าในเวลาเดียวกันผมไม่ต้องรอแบบข้อมูลตัวแรกเสร็จแล้วค่อยทำเข้าไปเอาโหลดตัวที่ 2ขึ้นโหลด8 อันเนี้ยจะถูกเซอร์วิสไปพร้อมกันได้ถ้าผมมี8 แบงค์เราเขียนโปรแกรมดีพอให้มันไปคนละแบงค์กันนะครับอันนี้ก็คร่าวๆนะครับก็สำหรับตัว high level detail นะครับเดี๋ยวขอ